In the past decades, AMD has been one of the most important companies when it comes to CPUs and GPUs, and most people interested in the area know the company and their products pretty well. But how did AMD got to where they are now? Where did they start? Before that, let's have a short word from our sponsor.
Today's video sponsor is GVG Mall,
bringing you lots of software deals like Windows 10, Windows 11, Office 2019 or 2021 with a new Windows 11 design, and for all of these you can use my SKG discount code for 30% off, getting a Windows 11 serial key for $22 and a Windows 10 one for only $15. Then use the key on your Windows settings and you'll have an activated system. AMD was formally incorporated by Jerry Sanders along with 7 of his colleagues from Fairchild Semiconductor on May 1, 1969. Sanders was an electrical engineer working as a marketing director and, like many others working there, grew tired of the lack of opportunity and flexibility. So he created his own company following the steps of Robert Noyce and Gordon Moore, who quit Fairchild Semiconductors to found Intel in July 1968. In the same year, AMD moved from its temporary location in Santa Clara to Sunnyvale, California, in order to immediately secure a customer base, being initially a second-source supplier of microchips designed by Fairchild and National Semiconductor. Having assured the guaranteed quality control to United States military standard, there was a big advantage considering the unreliability of most chips back in the days. The first proprietary product from AMD was released in 1970, the AM2501 logic counter, which was highly successful. In 1971, AMD entered the RAM chip market beginning with the AM3101, a 64-bit bipolar RAM. That and other things like the greatly increased sales volume of their linear integrated circuits made the company reach a total annual sales value of $4.6 million, and considering AMD was only 2 years old back then, the results were great. AMD went public in September 1972 as a second source for Intel MOS/LSI circuits, with products such as the AM1506 and the AM1507, which were dual 100-bit dynamic shift registers. Intel had also released their first microprocessor in 1971, the 4-bit 4004. And knowing that, AMD entered the market as well with the AM9080, which was a reverse-engineered clone of the Intel 8080. But in 1977, AMD entered a new phase, with Siemens, a German engineering company looking to enhance its technology expertise and enter the American market. Siemens purchased 20% of AMD stock, and both companies established AMC, Advanced Microcomputers, located both in Silicon Valley and Germany. This allowed AMD to finally enter the microcomputer developing and manufacturing field based on AMD's second-source Zilog Z8000 microprocessors. But only 2 years after, when both companies' visions for AMC diverged, AMD bought out Siemens' stake in the American division, closing Advanced Microcomputers in 1981 after switching focus to manufacturing second-source Intel microprocessors. Again. It was only in 1996 that AMD released their first in-house processor, the K5. The K was a reference to kryptonite, the only substance known to harm Superman, maybe implying that this processor line would be the only one harming their rival Intel, and the number 5 was a reference to the 5th x86 gen processors. This paved the road to the AMD processors that we have nowadays. But what about the GPU department? Well, it was not until July 24, 2006, with the AMD acquisition of the Canadian company ATI Technologies, that AMD had one. AMD paid $4.2 billion in cash and $1.2 billion in stock, for a total of $5.4 billion. This could very well lead AMD into a money shortage, and in October 2008, maybe due to that, AMD announced plans to stop producing the chips themselves, using Global Foundries, a multi-billion-dollar joint venture with Advanced Technology Investment Company. Going fabless and making that partnership gave AMD a very welcomed infusion of cash and allowed them to focus solely on chip design, which still stands today. As for branding, even though AMD bought ATI, their GPUs maintained the well-known ATI branding till August 2010, being then changed to the AMD brand name that we've known for years. Now that you know how it started, let's take a look at some of the AMD/ATI achievements since 1984. October 15, 1984. Industry's first single-chip burst error processor. AM9580 delivered an integrated solution that helped advance smaller disk drive technologies and accelerate the growth of the emerging personal computer market. If you want to know, we also have the AM9080, which was a copy of the Intel 8080 created by reverse engineering, that cost 50 cents to make and were sold into the military market for $700. January 9, 1986. Industry's first single-chip compression/expansion processor. AMD Lance AM7990 could expand and compress both text and image data simultaneously using 3 processing engines and 2-bus architecture, an important step for the development of highly efficient office automation equipment. February 19, 1986. AMD introduces industry's first 1 million-bit EEPROM. The AM27C1024 utilized AMD's unique CMOS process to create memories that could be erased by ultraviolet light and reprogrammed using a pulsed voltage. This allowed OEMs accelerate prototypes and customize products for different markets. July 1st, 1987. Industry's first graphics board compatible with every computer monitor, graphics interface, and software on the market at that time. ATI's VIP, VGA improved performance, was a part of the ATI Wonder series and was the first card offering support for multiple graphics standards and monitors, all in a single card. The Wonder series also added additional value with inclusion of a buzz mouse port, which normally required the installation of a dedicated Microsoft mouse adapter. Rough times. November 1st, 1995. Industry's first 3D graphics chip, ATI Mach 64 GT. The ATI Mach 64 GT, aka 3D Rage, was the first graphics adapter with a dedicated 3D processor, featuring DX5 support, 2MB SDRAM, 64-bit buzz, 60 MHz core clock, 83 MHz memory clock, and a 500 nanometers process node. And after 30 years, we're running 3500 MHz core clocks and 2 nanometers process nodes. Outstanding. March 27, 1996. AMD K5. The first independently designed socket-compatible x86 processor. It was the first x86 CPU to be independently designed by AMD. It was supposed to be released in 1995, but due to project delays, it was only released in 1996. Its main contenders were the Intel Pentium CPUs, and interestingly enough, benchmarks can still be found online, where the K5 100 MHz wins in some tests versus the Pentium 100 MHz. April 2nd, 1997. AMD K6 CPU helped dropping PC prices below $1,000. The AMD K6 was a CPU that you could use on motherboards designed for Intel Pentiums. You heard it right. You could use an AMD CPU on an Intel motherboard. How crazy is that? Also, although the K6 naming suggests a strong connection to the K5, the design was completely different since it was based on the model NX686 created by NextGen that was also bought by AMD. And well, the success of the K6 series helped paving the road to legendary CPUs such as the ones we're gonna talk about now. June 23rd, 1999. Athlon processor was the fastest x86 CPU available and utilized copper fabrication. As stated in a 1999 Tom's Hardware article, the AMD Athlon CPUs were finally stomping over the Intel Pentium III ones. And if you aren't old enough to remember those, they were pretty damn good CPUs. Unlike Pentium 4 that were like little volcanoes, while still being more expensive and slower than the AMD counterparts. But well, like I said, Pentium 3 CPUs were good, and we had the Pentium 3 600 being from 7 to 10% slower than the Athlon 600, and AMD had a 650 MHz version that was even faster, leaving Intel in the dust in every single benchmark. Even more in 3D Studio Max, where the Athlon 600 was no less than 45.3% faster. March 6, 2000. AMD released the first CPU to break the 1 GHz barrier, 1 billion clock cycles per second. The CPU was called Athlon 1000 and was a single-core CPU based on the K75 core. AMD currently uses the Athlon branding for lower-end CPUs, but back in 2000, Athlon was spanking Intel's top-tier Pentium 3 CPUs in almost every benchmark. AMD also released the Athlon 900 and 950, which were still competing very well with Intel CPUs, but the Athlon 1000 was definitely the star of the show. Although there were some aspects where the Intel CPUs with lower frequencies would still dominate, like for example when playing memory-intensive games like Unreal Tournament, where their full speed on dial to cache would make a big difference. April 22, 2003, the world's first x86-based 64-bit processor is released. The Athlon 64 is the third processor to bear the name Athlon. It was the immediate successor to the Athlon XP and the second processor after the Optron to implement the AMD 64 architecture, being the first 64-bit CPU on the consumer side. But what's the main difference in between 32 and 64-bit? Well, in its essence, it means that the CPU can actually process 64 bits in parallel for a single element in a data format. For the average user, it meant we stopped being limited to 3.2 GB of RAM and instead we could use up to 17 billion GB of RAM, with better multithreading abilities. In terms of gaming performance, the Athlon CPUs were just smashing the competition so hard that the fastest Pentium 4 at the time was just a bit over the lower-end Athlons. And if we take in consideration that AMD CPUs were less expensive in almost all countries, it made them a no-brainer for anyone looking for a new computer. August 31st, 2004. AMD releases the first native x86 dual-core processor. And it was the first x86 dual-core because the first non-x86 dual-core was the Power 4, developed by IBM. It seems AMD was far ahead, but not really, as the Pentium D was released in the same month and was also dual-core. Still, in most case scenarios, the single-core chips were still outperforming the dual-core ones due to higher frequencies, and since most applications only used one core, the higher frequency chips were usually on top. And one of the reasons that made the Athlon series a big success was because the Intel Pentium 4 and Pentium D CPUs were just bad in comparison. And it was only when Intel released the Core 2 series that the game really changed. But that was only 2 years later. March 20, 2006, ATI introduced the first 1 GB VRAM GPU. The ATI FireGL 7350 was the first workstation GPU to offer 1 GB GDDR3 SDRAM aimed at professional users and having a little brother with only 512 MB, the FireGL 7300. And this was also a dual-slot GPU, thing we didn't see much back then, and supported resolutions up to 3840 by 2400, which is above 4K. And it might not seem much, but for that time, it was like having 20K support now. The GPU also featured the X9.0C, a core clock of 600 MHz and a memory clock of 650. This all at only $1,599. November 19, 2007. Industry's first quad-core supporting scalable graphics. AMD Phenom quad-core CPUs platforms could deliver up to 2 teraflops of desktop processing power by harnessing 4 GPUs. Phenoms had a great naming scheme in my opinion, but the truth is that they were being outperformed by Intel's much faster and more efficient Core 2 Duo CPUs. And even the Phenom 2 CPUs were quite far from the Intel Core 2 quads in terms of overall performance. But they were still performing quite well in some benchmarks and supported scalable graphics, aka crossfire, leading the CPUs to still sell considerably well. June 16, 2008. The first GPU to break 1 teraflops barrier. The AMD FireStream 9250 was the first GPU to break the 1000 gigaflops of FP32 performance. It was based on the RX 770 graphics processor, but with 625 MHz GPU clock and 993 MHz memory clock, featuring the X10.1 support and 1GB GDDR3. It wasn't a card for everyone as it was a professional card, but it was definitely a nice mark in the history of GPUs. September 16, 2009. Industry's first sub-100 quad-core CPU for mainstream desktop platforms. The Athlon II series were based on the AMD K10 architecture, which was similar to the Phenom 2 series, however, unlike the Phenoms, it did not contain any L3 cache. The main point of these CPUs was to be affordable and deliver decent performance, which they did, with single, dual, triple and quad-core variants in 2009 for the M3 socket using 49nm and later dual and quad cores using 32nm for the FM1 socket, which was a socket for APU systems, but we're gonna talk about that later. By the way, bet you didn't know that there were triple-core CPUs back then, huh? But it was not only the Athlons, but also the Phenom CPUs that had triple-core variants as well. Pretty neat. January 4, 2011. World's first accelerated processing unit, APU.
Fusion is what happens when AMD technology, our partnerships, and our customers' dreams collide.
With its first name being AMD Fusion, later being called APU, Accelerated Processing Unit, the APU combined the CPU and the GPU on a single die, offering a faster and smaller solution for integrated systems. Before the APUs there were already iGPUs, the only difference is that they were set in a different die from the GPU, with the AMD APUs delivering those same integrated graphics in the same die. The first APUs used K10 CPU cores and HD 6000 series graphics, but their legacy isn't dead and they became a lot stronger with time. Nowadays we have APUs such as the Ryzen AI Max 395 Plus that can deliver an exceptional CPU experience with 40 RDNA 3.5 compute units that deliver close performance to a desktop RX 7600. Not even mentioning the lower power APUs that are also now used on laptops and handheld devices. June 11, 2013. Industry's first CPU to have 5 GHz stock frequency.
We've managed to unlock it, but how will people handle this much power?
AMD FX CPUs, the epic returns. Introducing the AMD FX 8-core processor, the world's first 8-core desktop processor, unlocked out of the box.
In 2011 we had the AMD FX series, and although the series was one of AMD's biggest fails, it was also one of the longer-lasting platforms they had. The FX series were amazing on paper, with a clustered multi-threading design instead of the traditional simultaneous multi-threading, but while clustered multi-threading offered a way better performance in terms of multi-threading with its modules instead of full cores, the single-core performance was quite bad, because the two cores inside the module were sharing the same LAU, arithmetic logic unit, and L2 cache. And with a low amount of software optimization for this design, things went terribly wrong. With the bad sales of the FX 4000, 6000 and 8000 series, AMD tried their luck with the AMD FX 9000 series, which were out-of-the-box overclocked to 5 GHz. Although these CPUs were still slower than their Intel counterparts in anything that wasn't multi-threading, and were also quite expensive, even more since they needed a very good motherboard due to their massive power consumption. Interestingly enough, the FX 8000 series CPUs like the AT350 are still viable for some things once tweaked, leading me to believe that this CMT design was maybe a bit ahead of its time. Or maybe it just wasn't good at all. Who knows? September 25, 2013, AMD introduces a new API. Mantle was a low-overhead rendering API aimed at 3D video games, developed in cooperation with DICE and designed as an alternative to DirectX and OpenGL. In 2015, Mantle's public development was suspended and in 2019 completely discontinued, but its source code was and is used in both DirectX 12 and Vulkan APIs, as AMD made a deal with Microsoft and later donated the source code to Cronus. And since Mantle was low overhead and closer to the metal, it was way more efficient than the X11 on AMD GPUs, delivering way higher frame rates, even more on CPU-heavy scenarios. Mantle definitely paved the way for newer APIs to come, and it was a very important step forward. June 16, 2015. First GPU to combine HBM and die stacking technology in a single package. The R9 Fury series came as something that would revolutionize the GPU industry due to a new form factor and HBM, high bandwidth memory. Still, that wasn't the case. Although the card was basically on par with the GTX 980 Ti, there were some reasons why it failed. One of the reasons was that the card was already so juiced up that the gains from overclocking were almost zero, while the overclocked 980 Ti was consuming less power than the stock Fury X, while most times being over 20% faster. Another reason was most likely due to the fact that it only had 4GB VRAM, while the 980 Ti had 6GB. And yeah, the 4GB were HBM, and in most titles it didn't make any difference due to the higher memory bandwidth, but in others it did. HBM2 was later used in VEGA cards as well, but this time AMD didn't make the same mistake, now adding HBM2 but 8GB. March 2nd, 2017. World's highest performance and lowest powered 8-core desktop processors. In 2017, the CPU market was boring to say the least, with Intel delivering around 5% performance increase per generation, while in some cases forcing the user to get a new motherboard, which somehow made fanboys happy, but made sane people really mad. And when the new AMD CPUs came out, they were a fresh breeze to the general public. And although some were carrying a bit of skepticism due to the early FX fiasco, that same skepticism was blown away as soon as people tried the so long-awaited Intel competitors, the Ryzen CPUs. AMD was looking for their place back in the CPU market, and although the Ryzen CPUs weren't the best gaming performers due to the lower IPC and frequencies, they hit hard, with more cores and threads than the competition, leading to better multi-threading performance, lower TDP, and a cherry on top of the cake, a $329 MSRP, which was $10 below the i7-7700K that had half the cores and threads, which made the Ryzen 7 1700 an easy pick for most people. AMD also promised several generations of Ryzen CPUs in the same socket opposed to Intel, that usually changed socket every 2 CPU generations. And that was also one of the things that led Ryzen CPUs to the top. People that bought a motherboard in 2017 can still use the most recent CPUs released in 2025. which added and still adds a massive value to the AM4 platform. April 11, 2017, industry's highest performance 6-core processor. 1 month after the Ryzen 7 1700, AMD targeted another performance tier, this time with the Ryzen 5 1600 that was up to 69% faster in multi-threading than the i5 7600K, its competitor at the time. This because although it was still slower in terms of single-core performance and overall gaming, to be honest, it had 6 cores and 12 threads as opposed to the stagnated i5 chip with only 4 cores and 4 threads, which even at the time was quite laughable. And with good reviews on the Ryzen 7 1700, the Ryzen 5 1600 also sold very well. One of the reasons was its longevity due to more cores and threads. In fact, if you compare both CPUs with recently released games, the i5 7600K will most likely perform worse than the Ryzen 5 1600, while it was performing better in 2017. Although that wasn't all fun and games, and the AM4 platform was plagued with memory issues and instabilities at release. The first Ryzen CPUs in their first iterations would struggle to run DDR3200 unless you had a Samsung BDI kit, and RAM prices were quite high at the time, so some people just took a step back from AMD platforms. Gladly, in its first year the RAM compatibility improved massively and more RAM kits could reach 3200. And if you grab a 2017 B350 motherboard nowadays and update its BIOS, you are most likely able to run DDR4 3400 on a Ryzen 7 1700 or Ryzen 5 1600, which is cool to see. June 27, 2017. World's fastest graphics card for machine learning development. Although we recently hear a lot about NVIDIA in anything related to machine learning, in 2017 the AMD Radeon VEGA Frontier Edition was actually the fastest card for machine learning development, supporting up to 256 terabytes of GPU memory. In terms of hardware, it was kind of an improved Vega 64 with 16GB HBM2. It brought a unique design in blue and yellow to match the colors of the professional AMD drivers, and in terms of benchmarks, it was usually in between the GTX 1080 and the 1080 Ti, in some cases like Lux Mark 3.1 being in front of those cards by a good margin. This while being priced at $999, which was way lower than the Quadro GPUs from NVIDIA. But in terms of gaming performance, this card was a failure, because even with prices as low as $500 after the mining craze, the GTX 1080 was still outperforming it in many titles. Even a GTX 1070 or a Crossfire RX 580 kit would outperform this card, while consuming less power. But well, for machine learning development, it was definitely worth it. August 10, 2017. Industry's first 16-core AGDT processor. 6 months after the first Ryzen CPUs got released, AMD was looking to reach a wider range of users, so they grabbed the stronger point of the Zen architecture, the multi-threading, and released their first AGDT processor. And correct me if I'm wrong, but I believe AMD always had server solutions, but they never had an AGDT processor before. But now they did, with the Ryzen Threadripper. The first Threadripper CPUs released were the 1920X with 12 cores and 24 threads, and the 1950X with 16 cores and 32 threads, being the first AGDT processors with that many cores. The 1950X was a direct competitor to the 10 cores 20 threads i9 7900X that was released 1 month before and was only $10 cheaper, even though it featured 6 cores and 12 threads less. And even though the first generation of Threadripper CPUs did not support AVX 512 instructions, they were already cannibalizing the Intel sales as they offered a higher number of cores at the same price. This paved the way to AGDT monsters like the Threadripper 9995WX with 96 cores and 192 threads, showing how much AMD evolved in terms of HDD processors in just a few years. November 6, 2018. World's first GPU to achieve 1 TB per second memory bandwidth. When everyone was waiting for a new GPU arc like RDNA and thought the VEGA arc was dead and ready to get buried, AMD announced the Radeon Instinct MI60, which used the VEGA 20 graphics processor, which was GCN 5.1. That was not only the first GPU to achieve 1 TB per second of memory bandwidth, but it was also the first GPU to use TSMC's 7nm process, although it was still using VEGA, and that alone was a limiting factor due to how squeezed the architecture already was. Its competitor was the Quadro RTX 8000, and although it was built using TSMC's 12nm process node, it still managed to outperform the MI60 in most scenarios. In terms of pricing, somehow I was unable to find anything about the MI60's MSRP, but I do know that the MSRP of the RTX 8000 was around $10,000. And even looking at the last prices available in stores a couple of years ago, we had the Instinct MI60 at around $2,500, while the RTX 8000 was still around $5,500, leading me to believe that although it was slower, it was not that bad of a deal. January 9, 2019. Industry's first 7nm gaming GPU. Well, Radeon VII is a GPU that most don't even know or remember, because besides being the first gaming GPU to use TSMC's 7nm process node, it didn't have anything to offer. It was released as the AMD's best gaming GPU 5 months after the RTX 2080 was released, and at the same price. This while being slower in anything gaming related and consuming more power. It was also pretty expensive to make due to being based on a multi-chip module design with a 7nm VEGA GPU plus 4 stacks of HBM2 memory, leading AMD to cease its production only 5 months after its release, and it was already being cannibalized by their newer and much cheaper RDNA GPU, the RX 5700 XT. And besides integrated graphics, this was the last GPU that used VEGA architecture, being followed by the new RDNA, RDNA 2, RDNA 3 and now RDNA 4 GPUs that were a massive upgrade featuring lower power draw and way better performance. August 7, 2019. World record-breaking data center CPU performance. If you don't know what EPYC CPUs are, well, like we have Ryzen CPUs for mainstream and Threadripper CPUs for HDD, we also have the EPYC for data centers and servers. The first AMD EPYC processors were released as well in 2017, and they did disrupt Intel's absolute domination in the data center market. But it was only in 2019 with the AMD EPYC 7002 series that AMD really turned the game in terms of performance and price performance, making cheaper and faster options, and that's the wet dream of every data center owner. And these CPUs held such a high performance per dollar value that the EPYC 7742 performed better than the Xeon Platinum 8280 while costing $3,000 less and consuming less power, making it the way to go for data centers as the owners could save money in the buying process and over the years with the electricity bills. November 7, 2019. Industry's first and fastest 16-core mainstream desktop processor. After the release of the Ryzen CPUs in 2017, AMD managed to do major advances in several fronts, and one of those fronts and those advances was with the Ryzen 3000 series, featuring the Zen 2 architecture, which brought way higher single-core performance and even better multi-threading abilities. This while also being the first CPU series made with TSMC's 7nm process node. And this generation also brought the Ryzen 9 branding, something that we did not have in the past two generations, featuring the first and fastest 16-core processor that you could use on your $100 motherboard. Just like that. When the first Ryzen CPUs launched, having a Threadripper with 16 cores and 32 threads was already an astonishing achievement, but having an even faster CPU with the same number of cores and threads on the consumer-grade motherboard was just out of this world. Also, the 3950X brought Zen 2 cores, meaning it was not only about multi-threading, but also about gaming performance. For a matter of perspective, the i9-10900K had been released 6 months later and it was still being pushed around by the 3950X. And even in terms of gaming, they were pretty much on par. This while the i9 was more expensive and used more power, making the 3950X an absolute bargain for users wanting heavy multi-threading with a little bit of gaming in the mix. October 8, 2020, world's fastest gaming CPUs. In 2020, Ryzen CPU's market share was getting bigger due to the big success of the Ryzen 3000 series that, although not being the fastest CPUs for gaming, were definitely the better ones in terms of price performance, at least in the higher tiers, since the i3-10100F and 11100F were still the kings in the lower tier market. But AMD wanted to dominate, and for that, they released the Ryzen 5000 series, rocking the new Zen 3 architecture, featuring up to 19% higher IPC over Zen 2 while maintaining almost the same power draw. This was mostly achieved due to improvements like the elimination of CCX, core complexes, or the fact that each core could now access the full 32 MB of L3 cache, instead of being limited to 16 MB per CCD. This made AMD almost gain the gaming performance crown that wasn't theirs for decades, and brought back their branding to premium instead of budget. Sadly, since the Ryzen 5000 series were smashing Intel 10th generation counterparts across the board, AMD pushed a substantial price increase that didn't make people happy, mostly on the 5600X that got an MSRP of $300, which was around the MSRP of the Ryzen 7 processors of the previous generations. The 5000 series also didn't have any CPU below the Ryzen 5 5600X for a long time, which made things quite odd and allowed Intel to dominate even more the sub-$300 market with the arrival of their 11th series, mostly with the i5 11400F and the i3 11100F processors. October 28, 2020, fastest AMD gaming graphics architecture ever. In the past few years, AMD GPUs were never a menace to the Nvidia ones, as AMD architecture was inferior in terms of gaming performance, but things start changing when RDNA cards got released, with the RX 5700 XT performing considerably better than the older generation VEGA 64, while being cheaper and much more power efficient. Although AMD did not have anything to compete with Nvidia in the higher tiers. And if they did, well, they scrapped the idea to maybe save some money. And Dr. Lisa Su said herself that AMD wouldn't be competing in the enthusiast level in that generation, focusing mostly on the price-performance ratio of the mid and lower tier cards. Gladly, the RDNA 2 GPUs, the RX 6000 series, were even better than anyone expected, featuring a whopping 2.5 times the performance per watt, and this time with GPUs getting released across all performance tiers, from the smaller RX 6500 XT to the bigger RX 6900 XT. These new GPUs delivered an astonishing performance per watt value, being faster and more power efficient than most Nvidia RTX 3000 cards, something that did not happen for years. And this was mostly due to the introduction of Infinity Cache that increased the cache values of GPUs by a huge amount and the crazy high frequencies that even the best NVIDIA cards could not touch, leaving a huge mark for the RDNA 2 architecture as the first one in over a decade to beat NVIDIA in terms of performance per watt, and the first one ever to have GPUs achieve 3 GHz on air like the little 6500 XT. November 16, 2020, world's fastest HPC accelerator for scientific research. As I told you before, the RDNA architecture was a major performance leap, and that same RDNA arc led to the creation of CDNA, the professional side of RDNA. The MI60 presented in this video before was the first GPU to achieve 1 TB per second of memory bandwidth since it was using VEGA architecture with HBM2, but it wasn't the best available. But this time, AMD also focused on a top performer with the AMD Instinct MI60, the world's fastest HPC accelerator for scientific research, but overall, a great fit for AMD in the HPC market. End of 2020. Smart access memory. In the end of 2020, AMD was losing to NVIDIA in terms of overall performance. Not by much, but still behind, even more in terms of ray tracing. So they took an existing technology called resizable bar and made their own implementation called Smart Access Memory. In conventional systems, processors can only access a fraction of the graphics memory, usually 256 MB, meaning that for a processor to call 1 GB of VRAM, it would have to make 4 separate calls. While with Smart Access Memory, the data channel gets expanded to harness the full GPU memory in a single call, reducing unnecessary work and optimizing performance. And this wasn't something created by AMD, and NVIDIA did release their own implementation of resizable bar shortly after, but it wasn't even close to AMD's implementation that brought astonishing performance gains in games like Assassin's Creed Valhalla, Forza Horizon 5, Horizon Zero Dawn, in between many others. The technology was firstly announced as working solely with the Ryzen 5000 and RX 6000 series, but its support was later expanded to the other Ryzen CPUs and even Intel ones, being also introduced for the RX 5000 series with the Adrenalin 21.9.1 drivers. Nowadays, this technology is the industry standard and is used with every single AMD, NVIDIA and Intel GPUs. March 15, 2021, the world's highest performing server processor. AMD had been in a pretty good position in the server market for the past few years, in terms of price performance, having the previous EPYC 7742 as the world's fastest data center processor, and in March 2021, the EPYC 7763 took its place, featuring the same 64 cores and 128 threads, but now using the much better Zen 3 architecture, with an increase of around 19% in terms of IPC, leading also to way better multi-threading performance and turning the CPU into the world's fastest server processor. June 22nd, 2021, AMD releases FidelityFX Super Resolution 1. By 2021, NVIDIA was pushing upscaling like it was the holy grail, and wanting it or not, AMD had to follow or they would get even more behind, as the LSS had been released over 2 years ago. So they released FSR1. Although this technology was using spatial upscaling, while NVIDIA had released the LSS 2.0 around 3 months before and was already moving to temporal upscaling using AI, which showed to be a much better solution. So by this time, AMD was at least 2 years behind NVIDIA in that same regard, and it was not looking good, with the only good thing about FSR being the fact that it was an open source solution. April 20, 2022, first generation AMD 3D cache with a Ryzen 7 5800X 3D. If you don't know what chiplet design is, it is basically how Ryzen CPUs are made. Instead of having a single monolithic die as in older generations, AMD found out that chiplet design was the way to go for more performance and better efficiency, having several dies in the same chip connected using Infinity Fabric. And in 2021, AMD made a step forward by announcing the first 3D chiplet technology that combined AMD's innovative chiplet architecture with 3D stacking to provide over 200 times the interconnect density of 2D chiplets, and more than 15 times the density compared to existing 3D packaging solutions. The first CPU shown running this technology was a Ryzen 9 processor. Strangely, the CPU that got released was the well-known Ryzen 7 5800X that, by having the 3D cache incorporated, was called Ryzen 7 5800X 3D. And even with slightly lower frequencies, going from 32 MB of L3 cache to 96 MB was a major uplift in terms of gaming performance, making the old 5800X from 2020 outperform the newer Intel CPUs like the 12900KS, while consuming way less power and being almost half the price. Obviously, the CPU would not outperform the competition in all titles, like CSGO, but it was outperforming them in titles where the cache was properly used, like Far Cry 6, GTA 5, and even Total War games, making it one of the best CPUs in the world, of course, and definitely the best when it came to price performance, especially since it could be used with an older and cheaper motherboard. May 12, 2022. AMD launches FidelityFX Super Resolution 2. By this date, AMD was giving Intel a run for their money on the CPU market. And on the GPU market, even though AMD was, with RDNA 2, the closest they were to NVIDIA in the past decade regarding graphics performance and features, they were still quite behind, especially when it came to upscaling technologies. The LSS2 was running AI and temporal inputs to produce decent upscaling quality, while AMD was still using FSR1 with the old and limited spatial upscaling. So, AMD released FSR2. It was a very welcomed addition that brought considerably better image detail and sharpness when compared to FSR1, but it was still quite far from the LSS2 in terms of temporal stability. Even with that in mind, upscaling wasn't such a big thing like it is nowadays, and even though the LSS2 was considerably ahead, FSR2 was open source and was a welcomed addition to the AMD software solutions, but once again, AMD was at least 2 years behind. September 27, 2022. AMD launches Ryzen 7000 series, the fastest core in gaming. By 2022, AMD was in a really good place when it came to the CPU business, with consumer, HDD and server solutions selling quite well. And only 6 months after releasing the Ryzen 7 5800X 3D, they released the Ryzen 7000 series. These new CPUs featured the Zen 4 architecture that was different in many aspects. Zen 4 was the first AMD architecture to use DDR5 memory, while Intel was using it since the end of 2021, and was the first AMD CPU architecture to boost frequencies constantly over 5 GHz, with boost frequencies reaching as high as 5.7 GHz. This was a breakthrough especially for AMD's mid-tier CPUs, where the Ryzen 5 7600X was considerably faster than the Ryzen 5 5600X, matching or outperforming the later released Ryzen 7 5700X 3D, even without 3D cache, This, of course, due to architectural changes like the way higher clock frequencies, decoupled Infinity Fabric, and doubled the L2 cache. AMD later added 3D cache to the 7000 series, starting with the Ryzen 7 7800X 3D, claimed the world's best gaming CPU. That was not only faster than the Core i9 14900K in most titles, as it was also consuming half the power in most of them, making the 7000 series a turning point for AMD, where they finally got the gaming performance crown. Although, apart from the X3D ones, the 7000 series CPUs did not sell much at the beginning, as they needed the expensive X670 motherboards, and of course, DDR5 that at the time was quite expensive, selling much better after the B650 motherboards were released and DDR5 prices went down. December 13, 2022. AMD launches the RX 7000 series, the first GPUs built on chiplet design. By the end of 2022, AMD was on a very good position in terms of CPU market, but when it came to the GPU side, they were a bit behind. RDNA 2, the RX 6000 series, was the closest AMD had ever been to Nvidia maybe in the last decade, with the RX 6950 XT performing very close to the RTX 3090 in some titles, while costing around $500 less. Overall, the RX 6000 series were extremely good value, losing only by a lot in terms of ray tracing performance, and with FSR2 being a bit worse than the LSS2. But to be honest, these things weren't that important back then. Although, when the RX 7000 series released, the fastest card of the series, the RX 7900 XTX, was 30% faster than the RX 6950 XT, while consuming more power, being nowhere close to beat the RTX 4090. And it was also plagued with some early driver issues that came with a huge architectural change that came from using multi-chip module design. With games like Forza Horizon 5 performing worse than the previous generation, idle power dropping through the roof, and there were some more in the mix. This on top of costing almost the same as their Nvidia RTX counterparts that had almost no issues and delivered better ray tracing performance, and had the LSS3, a considerably better upscaler, and now with frame generation. Features that by the end of 2022 were starting to become important. RDNA 3 sold much better after some months or maybe a year after being released, as driver updates fixed most issues and prices went down a little bit, especially for cards like the RX 7900 XT, that at $650 were a very good deal. But even though RDNA 3 was an underwhelming generation, it paved the road for future generations to come with multi-chip module design like the so long awaited UDNA architecture. April 25, 2023. AMD introduces Ryzen Z1 series for the handheld consoles. By 2023, AMD was having a blast on the CPU market, outselling Intel by a lot in terms of the consumer market, making CPUs and GPUs for the new consoles and expanding their wings on the AGDT and server markets. But AMD found a way to go even further and entered the handheld consoles market, with the Ryzen Z1 series, a truly remarkable APU that used 8 cores and 16 threads of Zen 4 architecture, mixed with up to 12 RDNA 3 compute units, delivering up to 8.6 teraflops of performance on an extremely low power envelope of 30 watts. With AMD dominating the handheld console market from Steam Deck to almost any other device. April 30, 2023. AMD launches the Ryzen 74 series AI processors. AMD was leading in many departments, and even though AI was a thing people have been hearing about for some years, it was by the end of 2023 that it seemed like everything was about AI. AMD didn't want to be left in the dust like they were in the past, so they released the Ryzen 7040 series APUs, the first consumer APUs to pack an NPU inside. The 7040 series used Zen 4 CPU architecture, RDNA 3 GPU architecture, and the first iteration of XDNA NPU architecture. An NPU is a neural processing unit made to do AI workloads, like large language models, image generation, video generation, and much more. These APUs were also very powerful and were used for both laptops and mini-computers, with the Ryzen 9 7940 AGS, for example, bringing the Radeon VII 80M that, according to my own benchmarks, was very close to the external RX 580, but with a full CPU plus GPU package consuming only 60 watts. Intel also tried to compete with some integrated ARC graphics, but they weren't really on par with the Radeon VII 80M, the same Radeon VII 80M that was later inside the Ryzen 8040 series, the 7040 series refresh, and the 8000G series, desktop APUs that were released by AMD in 2024. September 29, 2023, AMD launches FidelityFX Super Resolution 3. By the end of 2023 or 2023, upscaling technologies were already a big thing that made people buy or not a certain graphics card. And with Nvidia releasing the LSS 3, AMD needed to improve their game, especially if they wanted to sell their RDNA 3 cards. So they released FSR 3. But even though FSR 3 wasn't 2 years late like FSR 2 was, it was still quite late since the LSS 3 had been released almost 1 year before. FSR 3 launched with only 2 titles, Immortals of Avium and Forspoken. Titles that didn't sell that well, and to make things worse, FSR 3 was basically FSR 2.2 upscaling plus frame generation. Meaning that the only new thing was in fact frame generation that was also plagued with some issues at launch, not supporting variable refresh rate and having very poor frame times, meaning that it couldn't be used with FreeSync and you needed to use it with VSync and at your monitor's maximum refresh rate in order for it to work as intended, which was a bummer to be honest. Gladly, that was fixed after some months and the experience got much better, and even though it wasn't featured in many games, it was still a success, especially because unlike the LSS frame generation that only worked with the RTX 4000 series, it could be used with older AMD cards and even older Nvidia ones, making it a standard for anyone that wasn't using an RTX 4000 series. And because it was open source, modders were able to implement it in many titles that weren't officially supported. August 15, 2024, AMD launches the Ryzen 9000 series Zen 5. The Ryzen 7000 series wasn't such a huge improvement at launch, especially with CPUs like the Ryzen 7 5800X3D and 5700X3D being around, with much cheaper motherboards and RAM kits, although they started selling quite better after the prices of the previous stabilized. As for the Ryzen 9000 series, people were expecting very good things, in terms of performance, but in that regard, that generation was kind of a flop, with lots of people and reviewers even calling it Zen 5%, as generally, the performance difference from the 7000 series would be exactly that, 5%. Although from my own benchmarking, the Ryzen 7 9700X was around 10% faster than its predecessor, but you had to unlock the power limits to do so, and those were big points of the Zen 5. Improved instructions making games like Hogwarts Legacy and The Last of Us perform quite well, lower power draw especially with the Ryzen 7 CPUs, and lower temperatures due to better substrates, not really the performance. But we can say that those points were only appealing for people upgrading from really old CPU generations, and it was only with the release of the Ryzen 9000X 3D series that the 9000 series evolved and became what they should have been from the beginning. November 7, 2024, second generation AMD 3D cache. By 2024, the 3D cache CPUs were a massive success for AMD in terms of performance, sales, and even prestige, with everyone knowing that the X3D processors were great for gaming. But they were not perfect. Having 3D cache vertically stacked on top of the CPU cores was not optimal and generally led to higher temperatures, which were also limiting CPU frequencies and performance. So, to fix those problems, AMD introduced the second generation 3D cache that moved the stacked cache from the top of the CCD to the bottom of the CPU chip using direct copper-to-copper bonding and through silicon vias from silicon to silicon communication. And while this might not seem much, this change alone allowed AMD to fix the faults of the previous generation. The temperatures were much lower, and much lower temperatures allowed for 500 MHz base clock over the Ryzen 7800X 3D while still maintaining lower temperatures, with AMD also unlocking for the first time ever overclocking on the X3D processors. January 5, 2025, AMD launches the Ryzen AI Mach series. At the beginning of 2025, Zen 4 was pretty solid and Zen 5 was starting to sell better, especially because of the 9000 series X3D CPUs. But AMD wasn't done yet, so they focused on the APU side, delivering what I personally consider one of the greatest achievements in the last decade in terms of APUs. The previous top-tier APUs were the Ryzen AI series, with CPUs like the Ryzen AI 9 AGX 370 already packing 12 Zen 5 cores and 16 RDNA 3.5 compute units, which were already beating any of Intel's offerings by a good margin, being faster than the discrete RX 580. But the Ryzen AI Mach series took things to a whole other level, bringing 16 Zen 5 cores, which is not that impressive I know, but an insane integrated graphics with 40 RDNA 3.5 compute units, effectively increasing the maximum amount of compute units with integrated graphics by 2.5 times, from 16 to 40. This all in a 120 watts package, which is even more insane. This meant that you could have an APU with a graphical performance very close to cards like the RX 7600 XT or the RTX 4060, with a whole chip consuming less than those GPUs alone, making it one of the most impressive and most interesting technologies of the time. March 6, 2025, AMD launches the RX 9000 series RDNA 4. AMD was doing very well in many fronts: CPUs, APUs, servers, but they were still lacking in one department: graphics cards. Nvidia was still dominating in several aspects, especially after the RX 7000 series that were much far from the RTX 4000 series than the RX 6000 were from the RTX 3000. Nvidia had the upper hand in terms of performance, efficiency, and features, with RDNA 3 cards having the upper hand usually when it came to VRAM capacity and sometimes pricing. So AMD released RDNA 4. RDNA 4, like RDNA 3, was an architecture mostly focused on gaming, with AMD following the same strategy they had with the first RDNA cards, not releasing any enthusiast level ones, maybe to put more time, effort, and money on the next generation to come. The best RDNA 4 card was the RX 9070 XT that, even though had only 64 compute units, was able to match or sometimes outmatch the RX 7900 XTX that had higher power draw and 96 compute units. RDNA 4 brought immense upgrades in some fields. Frequency got boosted to up to 3.5 GHz with cards like the RX 9060 XT, efficiency got improved considerably when compared to the previous generation, and AI and ray tracing performance also got a huge performance increase, with the RX 9070 XT being over 20% faster than the RX 7900 XTX in games like Cyberpunk 2077, even with much less physical units. And this card sold very well because even though they weren't the best performers around, they managed to be considerably faster and more efficient than the previous generations, while generally costing less. And of course, they brought long-awaited software features. March 6, 2025, AMD launches FidelityFX Super Resolution 4. As stated before, RDNA 4 brought lots of new features at launch, like the AMD Chat, Radeon Image Sharpening 2, and even improved codec quality, meaning that people focusing on recording and streaming could now see AMD cards as an option, because they were finally a worthy one. But the most awaited feature was, without a doubt, FSR 4. We could say that by the time RDNA 4 cards released, DLSS was already the main selling point of the NVIDIA RTX cards, not ray tracing performance, but DLSS, with features like DLSS Super Resolution, DLSS Frame Generation, Multi-Frame Generation, Ray Reconstruction, and so on. But the biggest seller was definitely the DLSS Super Resolution that was miles ahead of AMD's FSR 3.1 in terms of upscaling quality. And people were moving from AMD to NVIDIA because of it, especially since the DLSS 4 had been released some months before and brought the new transformer model. That was a major quality uplift in many areas. And AMD knew they had to follow once more, and they did, with FidelityFX Super Resolution 4. This iteration was miles ahead of the previous FSR 3.1 and the first AMD upscaling technology to use AI. And it was definitely a good call, as quality-wise, FSR was closer to the DLSS than it ever was in the past, with the difference being really hard to tell unless you were comparing them side by side. This made the RX 9000 series sell quite better than their predecessors, as FSR 4 was actually good. And it could be used with almost any game that supported FSR 3.1, and if the user wanted to go even further, they could use the OptiScaler mod and use it even in older titles. Second half of 2025, AMD launches FidelityFX Redstone. As I am writing this video, FSR Redstone still isn't released, but it just shows that AMD not only wants to keep up with NVIDIA, as they also want to surpass them. FSR 4 was a major uplift for the FidelityFX Super Resolution side, but AMD was and still is losing when it comes to overall FSR features, and that is where Redstone comes in. Featuring things like neural radiance caching and machine learning ray regeneration to increase performance and quality in ray traced and path traced scenarios, and machine learning frame generation as well, because even though AMD had machine learning upscaling with FSR 4, frame generation was still using a software algorithm with FSR frame generation 3.1.5. We saw how AMD started, and we're seeing how it currently is in 2025. There would be way more to talk if I wanted to, but I believe we covered the most important achievements or interesting achievements so far. What is the future going to bring us? Nobody knows. It could be better or worse, but things are definitely getting interesting. And before ending this video, I want to leave you a big note of appreciation if you watched the whole video, and if you did, it would be amazing if you were kind enough to let me know in the comments section what is your opinion on the video and on AMD's future. If you like the style of the video, if you like the editing, if you like the narration, and regarding AMD, if you think they will get better or they will get eaten by any other companies that can, well, surface. Just again, thank you very much, leave your comment in the comment section, and see you in the next one.